All right, today we're going to go ahead and go over calculating molar mass. So first I'm going to go over the concept of what is a mole, and then we will go into the calculations, which aren't very difficult, okay? All right, so if we want to find the molar mass of any compound, first we need to understand what is a mole. Okay, so in chemistry, we say that 1 mole equals 6.023 times 10 to the 23rd of either, that can be particles, so it can be particles, it can be atoms, it can be really anything. So a mole, whatever we're talking about, mole can be particles, atoms, compounds, but it's this amount. Okay, so let's look at an example here. So let's say I have 1 mole of carbon. 1 mole of carbon. And the reason scientists use this is because atoms are very small. So we want to take things that are very small and quantify them into easy to work with numbers. Okay, that's why we created the mole. It's just a made up number, kind of like 1 dozen, right? Like we know 1 dozen equals 12. Same thing with this. Okay, so say we have 1 mole of carbon. So if I were to put this 1 mole of carbon on the scale, so let's say I have a flask here, right? I have 1 mole of carbon. What does that mean? Well, that means that I have, inside of this, I have 6.023 times 10 to the 23rd atoms of carbon. Okay, so obviously that's a lot of carbon molecules, right? Each carbon molecule looks like this. So we would have that many if we had 1 mole. 6.023 times 10 to the 23rd. Let's say I put this on a scale, right? Now I wanted to know, how much does this weigh? Well, 1 mole of carbon, scientists have figured out, weighs, well, all we actually have to do to figure that out is look at our periodic table, and our mass is actually our molar mass. So that bottom number doesn't represent the mass of 1 carbon, because 1 carbon, remember, atoms are extremely small. 1 carbon is going to pretty much weigh nothing. But what this number represents, it represents the mass of 6.02 times 10 to the 23 atoms. So if I were to put this on the scale would read 12.01 grams, right? All right, what if I were to take another example? Let's say I had 1 mole of oxygen, right? Let's say I had 1 mole of oxygen. So let's say theoretically we were able to get into a container and we just had 6.023 times 10 to the 23 atoms of oxygen inside this container. Okay, so if we remember oxygen atoms, so we have a bunch of oxygen atoms in there, right? Oxygen atoms, they're not bigger than this, but they actually have a bigger mass. That's because carbon, if we look at a carbon molecules, each carbon molecule has 6 protons and 6 neutrons, right? Whereas oxygen, each oxygen has 8 protons and has 8 neutrons. I'm not talking about electrons because electrons don't contribute to the mass. So if I have 1 carbon molecule, it's going to have a smaller mass compared to 1 oxygen, because oxygens have more protons and more neutrons. If I have 2 carbons, they're going to be smaller than 2 oxygens, right? It's going to weigh less because these are always going to have more protons and neutrons. If I have 6.023 times 10 to the 23rd carbon, it's going to be the same as, it's going to be always less than this. Okay, so if I were to put this on the scale, and again, I just have to find them. If I want to find what the weight is, the scale would read just the mass of that. Okay, so I go to my periodic table. I know oxygen has a mass of 15.99. Okay, so my scale would read 15.99 grams. Okay, that's the mass of this many particles of oxygen. Okay, it makes sense that this 1 mole of this weighs more than 1 mole of this, because 1 mole of this, even though it's the same amount of atoms, each of these atoms have more protons and neutrons. So it's going to have a greater mass. Okay, so that's the concept, and we'll keep kind of practicing this concept. sometimes it's difficult to get right off the bat. So now let's go over how do we actually calculate molar mass. Okay, so I'm not gonna list any steps because we're just gonna kind of go through the process. So let's say I have this compound here, chlorine. It occurs in the natural form of Cl2. So if I want to find the mass of this, well, I want to go ahead and find the mass of chlorine. So the mass of chlorine is 35.453. Okay, I have two chlorines though, because this 2 represents 2, so I'm going to multiply times 2. So it's going to be 2. I would multiply times the molar mass of the compound. So it'd be 2 times 35.453. Okay, grams, and that's going to give me my molar mass. So in this example, my molar mass would be 2 times 35.453 would give me 70.906. I'm going to round. For all these problems, I just want you to round to that first decimal. So my mass is 70.9 grams. Okay, this was a 0, so that's why I kept it here. If this was greater than 5, then we would round up to 71. Let's look at a few more examples. Let's get a little bit more complicated now. Next example, water. What is the mass of water? H2O. H2O. Right? Well, what compounds do I have here? I have hydrogen and I have oxygen. How many oxygens do I have? I have 1. Right? Because there's an invisible 1 there. How many hydrogens do I have? 2. Multiply both of these by their molar masses. The molar mass of oxygen is 1.008. What's the molar mass? The molar mass of hydrogen is 1.008. The molar mass of oxygen is 15.99. 15.99. Okay. Then we just multiply. Right. So this is going to give us 15.99 because that's just 1 times that. Then the other one's going to give us, if we go 2 times 0.008, 1.008 gives us 2.16. So 2.016. Last of all, we want to find the total mass, so we have to add that up. Okay, we didn't add it up here because we only had 1 compound. So we add it up. So again, you don't have to do this in your head. Plus 15.99 gives me 18.006. That's just going to round to 18 grams. Okay. All right, let's keep going here. I'm going to go ahead and do the molar mass for NaOH. How do I know that these are 2 separate compounds and not just 1? Remember, capitalization matters. Capitalization tells me if I'm dealing with 1 atom or 2 atoms. Okay, so because both of these are capitalized, they're separate atoms. So here I actually have sodium, I have oxygen, and this OH isn't together. It's hydrogen because they're both capitalized, so they're both atoms. Okay, so they all have 1, so I'm just going to put 1 so I can show you guys the example, but I'm going to multiply times their molar mass, right? Sodium has a molar mass of 22.99. Oxygen has a molar mass of 15.99. And hydrogen, as we just saw, would be 1.008. Okay, we multiply all these, it would essentially give us the same number. Then we would go ahead, we would add this up. Finally, take all the masses, you add them up. And I didn't have to multiply in this case because it was all 1, right? So I would go ahead and just add this up. So it'd be 22.99 plus 15.99 plus 1.008 gives me a total mass of 39.9. Okay, so this 9 is actually going to round up because this is greater than 5. So it's going to end up being 40 grams, right? Because this 9 rounds up, so this becomes 40. 90 grams. Okay. All right, let's look at another example here. So we'll get a little bit more complicated in this example here. So this will be the last example. I have lithium, sulfate. That's something like SO4, 2. Okay, so now I got to break down and kind of look at what compounds I have. Well, I know I have lithium. I have one of those. Okay, because this 2 only applies to whatever's in here. I have sulfur, and this is an S. This is separate because this is a capital S. This is a capital O. If there was a big S, little o, then they would be different. Okay, but there's going to be separate compounds. So the 2 applies to this, so I have 2 sulfurs. Oxygens have 4, but I have 2 of those compounds, or 2 of these SO4 molecules. So 2 applies to this. 2 times 4 would give me 8. So I have 8 oxygen molecules. Okay, I go ahead and I find the molar masses. So the molar mass for lithium, look at my periodic table, will be 6.941. So times 6.941. Sulfur will be 32.066. So 32.066. Oxygen is 15.99. As you do it more and more, you're going to start kind of remembering a lot of these molar masses. Okay, so you can be able to memorize them. So 1 times this gives me that, right? I don't have to use a calculator for any of that. Next one, it's going to give me, so I go 2 times 32.066 gives me a total of 64.132. Last of all, 8 times oxygen, 8 times the molar mass of oxygen gives me 127.92. Last of all, add them all up. So this plus 64.132 plus 6.941. It's going to give me 198.99. Okay, so this is my actual value. If I rounded this, it would actually give me, if I rounded this to the first decimal, this is greater than 5, so this would round up, and this would end up being 199 grams. Okay, if you put this, it's not wrong, but if you round it, that's kind of what I'm looking for in the problems. Okay, and that's pretty much it. So really the process is you list out the atoms you have, you list out how many you have of each. So we've already learned how to do that when we're doing counting atoms, and you just multiply by the molar mass. Okay, and what does this at the end of the day, we also have to understand, what does this mean? This means that if I have 6.023 times 10 to the 23 atoms of sodium hydroxide, that would weigh 40 grams. If I had 1 mole of water, it would weigh 18 grams. If I had 1 mole of CO2, it would weigh 70.9 grams. So that's what these numbers mean. It just tells us the mass of 1 mole of that compound.